Alright, now for the tricky part of this week's lesson. What I'm about to show you is a way to toggle the state of your LED with a single button press. What I showed you in the last portion was for the state of the LED to match the state of the button, which means that if you wanted your lights to be on in the room, you would have to keep your finger on the switch, which is clearly impractical. So what I'm going to first do is start this simulation and show you that when I press this button, it is going to change the state of my LED each time. Now, it seems like a really simple concept, but as you can start to peek at the side here in our code, it involves a little bit of thinking and a lot of terminology. So let's get started. Before we get into the code, you're probably seeing that there are a whole number of variables that you probably haven't seen or used before, and I've kind of done that intentionally just to expose you to the large number of different types you might come across as you continue your programming journey. Before I get into exactly what the variables are doing, just keep in mind what fundamentally a variable does. It stores information, and just like in real life, we store things in boxes. You'll have to choose the appropriate box depending on the object you want to place inside. Well, programs are exactly the same. We have different types of variables to store various kinds of information. So you'll see on lines 1 and 2, storing the red button and LED spaces, those are very small numbers, and the byte is basically the smallest kind of variable that I can use. On lines 4 and 6, you'll see I've chosen an integer. An integer or int variable stores yet a slightly larger number than what bytes can hold. On lines 10 and 11, the type of variable known as a long store larger numbers still. And there's even one just above long called the unsigned long, and it can store our largest numbers when dealing with coding. Let's take a look now on line 5, where we have something called a bool, or Boolean integer. Essentially, these are logic-based variables that store either a true or a false state. A lot of times I will use a Boolean variable when I just want to see if something is happening or not happening. Lines 1 and 2 are fairly straightforward. We have byte variables that simply store the position of the red button and LED. Next, let's talk a little bit about buttons. Earlier we had mentioned that we have to set the state of the button ahead of doing anything because they will tend to float if we don't. We can either pull them down using hardware and a large resistor, or we can pull them up using software and an input pull-up resistor. Now, another shortcoming of buttons and switches of their kind is that when they are pressed, they do something called bouncing, where they basically toggle between a high and a low state many times in a very short period, and it can really alter what happens in your code when you're doing something like toggling. So we're going to have to create a couple of extra variables here in order to make sure that we're toggling the way that we want to. This is going to be called debouncing our button. So in order to do that, I have to create some variables here in my global section. Number 1, I have to have the state of the red LED. And initially we're going to set it to high, which means when our code starts, our LED ought to be on. On line 5, I'm going to have a Boolean variable that is going to store the state of the red button, meaning is it being pushed or is it not being pushed? So because we're using our pull down resistor here, when it's not being pressed, the red button state should be false, and when it is being pressed, it should be true. Now I am going to have to check what happened to my button in between presses, so I'm going to need a third variable here called the previous red button state, meaning what was going on just before I went ahead and read it, and you'll see why a little bit further in the code. Now I've just used a term called debouncing, which means that I want to ignore any potential micro toggles of my button when I think I'm only pressing it one time. And in order to do this, we're going to use a timing construct built around the function called millis, which I'll get to in a little bit. It is a massively powerful thing to be able to master. It is a little tricky the first time through, but suffice it to say, I'm going to need a few variables in order to store some times. And they are going to get rather large rather quick because if you remember, in this programming language, we count time in milliseconds. So for every 1 second that passes in real time, that is 1,000 milliseconds, and you can see how those numbers get very large. So I'm going to need a variable to store the time in, and I'll call it time. And I also want to set a variable called debounce. And this is the amount of time that I want to wait for before taking a second reading to make sure that I skip all of those little micro bounces that I don't recognize in the real world. Now in this case, my void setup is going to be very easy. I'm not even going to be printing to the serial monitor. I'm simply going to initialize my red button as an input. Remember, because it's being pulled down with a resistor on the breadboard, that's all I need to write. And I'm going to declare my red LED as an output. Before I get into the logic flow of this algorithm, I want to introduce you to the function known as millis. Anytime you call millis in a program, it essentially returns the number of milliseconds that have passed since your program was started. And we can use this as a timing mechanism when trying to trigger different things within a code. So at this point, your head may very well be spinning, and it's totally normal because you are new at this. And you might be asking, why did I go through all the trouble of using that entire millis counting construct instead of just using good old delay? Well, I'll tell you why. The delay function is something known as a blocking function, which means that while it is being run, literally nothing else can happen in the code. You are stuck delaying or waiting for whatever amount of time is in there. Now, granted, this is only 200 milliseconds, and it's not very long, but there may be other timing mechanisms that you want to use somewhere down the line where you don't want your entire code to stop simply because you're waiting for a condition to be met. Think of it this way. Walk up to a deli counter and order a turkey sandwich, and have them tell you it's going to be 10 minutes. Well, think about if you were able to do absolutely nothing in the amount of time that 10 minutes had to go. That would be the equivalent of a delay. You would literally have to stand there waiting for your sandwich until it was all finished, as opposed to walking away, having a seat, taking out your phone, checking your messages, and periodically glancing down at your clock. And if you see that 10 minutes hasn't passed, then you can continue going on doing whatever you'd like, checking social media, playing a game. Every now and then you're going to go back and look at your clock. And essentially what's going to happen is, after you've realized that a large enough amount of time has passed and your turkey sandwich is ready, you will then stop what you're doing and then go get your turkey sandwich. That's exactly what's going on in this little millis section right here. So instead of stopping everything for 200 milliseconds, all we're simply going to do is allow the compiler to go through our code over and over again until that clock has struck the amount of time we've set, and in this case the debounce was 200 milliseconds. The more you practice with this, the more intuitive it will become, but I thought it would be good to expose you to it early on in the process. Alright, strap in, because here we go. Let's get into the void loop now. Line 21 is really self-explanatory. We saw it in the last portion. The red button state, meaning what's going on with the button, is simply going to be set equal to the digital read of the button pin. Meaning, if I push the button, then it is going to be a 1, and if I am not pushing the button, it is going to be a 0. Now, provided I don't push the button, essentially nothing else happens in this code. Because what we're going to see now on line 23 is something known as a control structure. So in logic, essentially what we're going to say is if, and then anything that happens in these parentheses, those are the conditions of the if statement. So they all must be met in order to enter what's going on inside the curly braces. So let's meet the conditions that we have to set in order to get something to happen here. So the first condition is if the red button state is true. Now I want to point something out here that's really important. Notice that I'm using a double equal sign. When I am using a double equals, that is the logical equivalent of it is equal to. I'm checking for equivalence. I'm looking to see that the red button state is actually true. When I am using a single equal sign like I am on line 21, that is known as an assignment operator, and that's if I want to set the value of something equal to another object. So on line 23, I first want to check, is the red button state actually true, which means I am pushing that button. Next, you're going to see a double ampersand. That double ampersand is the equivalent of saying and. So not only do I have to be pushing the button, I also have to have the previous button state, meaning what was going on just before I pushed it, equal to low. And you're going to see why that actually matters in just a moment. Next, there's a third condition, so there's another double ampersand. So when you're using ands in logic, it means that all of these things have to be true in order to meet the if condition. And the third condition is our timing construct. So in this case, millis is being called, and I have to make sure that the time that has gone by minus the beginning, which when we first started this program, time is set equal to 0. We're going to change that as this goes on. But essentially, as soon as the program starts, millis begins counting. And if I take that and subtract 0, it has to be larger than my debounce time, which was 200 milliseconds from earlier, which means that I am not going to pay attention to any little micro pulses of my button for the first 200 milliseconds after I've pressed it, and that is effectively going to debounce and prevent us from getting false positives. So again, provided that my button is pressed, right before it was not being pressed, and the appropriate amount of time has gone by, I am now going to come into what's going to be executed in my if condition, and that is simply I'm going to toggle or I'm going to switch the state of the red LED. Now initially, you'll see that the red LED state was high. We started our code with it on. I am now going to assign it the value of the opposite. So by using that exclamation point, or as programmers will call it, a bang, when you see that bang precede the next variable name, it means not. It means the opposite of whatever it was before I entered this condition. So if I entered this condition and the red LED state was high, it is now going to be set to low. Okay? I am then going to reset my timing counter to be whatever millis is counting right now. So essentially, I'm going to reset when I check my watch, and I'm going to be able to continue on with what I am doing. Finally, now that I'm out of that little if condition, I am going to digitally write to my red LED whatever the red LED state currently is. So that's going to turn my light on or off depending on whatever went on inside of my if condition. And then finally, I'm just going to take a quick peek at my button to see if I'm still pushing it. If we logically think about what's going on here, if I push the button when I simulate my code, and I turn my light on, the next time through, if I didn't take my finger off the button, it would continually just flip on and off because it thinks I want to go ahead and switch the state of this red LED each time. That's the reason for this second condition up here. It is looking to make sure that I've taken my finger off the button and have repressed it before changing the state of that LED. Okay, so we've now gone through all of the code, and we're going to simulate it one more time just so you can take a peek at how it works. So essentially, the red button state currently is 0. It's false, so nothing is being executed right now. My red LED is still in the high state that we set it to when the program started, and now what we have to do is take a look at some things. First of all, the previous button state, I set that to low to begin, so that's already good to go for me. So when I think about my condition, I have to push my button, low is already being met, and now I've got to go ahead and take a look at 200 milliseconds passing since the time I've pushed my button. So I'm going to go ahead and do that. And now, in a blink, the red LED state has been set to the opposite of what it was. It is now low. Time is being reset. We have now digitally written to the LED that low condition, and now we're going to make a read of the previous button. It is going to now see that the red button state is 0. It is low because I am not pushing it anymore. So when I come back up to the top and I push the button again, I've equivalented it to true. I have now made the previous button state low. The appropriate amount of time has passed. I've toggled my red LED state again. I've written the LED to that state. I'm checking to see that things are going. Now, if I were to come here and I would continually push, which I am right now, my thumb is still down on the button, notice that my light isn't blinking on and off, because right now the button state is high, and on line 33, I am not getting that second condition of my if clause that says it has to be low. Once I now have just taken my finger off of the button, now it's reset and it's ready to look for another toggle. Your challenge here is simply going to be to try and make this happen for the green LED. I don't recommend that you put them together right now. It's a pretty difficult code to do. So all I want you to do is switch the variables inside of the code to match the conditions that would have to be met if you're using a button with a pull up resistor instead of a pull down resistor, and I'd like you to get the green button to toggle on and off with the green LED.